Can you guys see my screen now?
Yeah.
Yeah, cool. Okay, open up this to present. Okay, that's cool. And then, I don't know. Am I allowed to close it here and still? No, damn it, that's so annoying. Okay, cool. So today, these concepts they're going to be pretty tough, I reckon. It's quite interesting, and I think if you think about it in terms of what the English words mean, then maybe you'll be able to figure it out without much trouble. And yeah, I think that's what you must keep in mind with this section. All of the words and stuff, they correspond to pretty complicated programming topics, but the words always have the same meaning that they have in just normal common parlance, if you want to call it that. So cool. I want to begin by just setting up an example again, and while we're setting up that example, we'll also revise a lot of the class topics that we covered last week. So yeah, I'm gonna switch over to Rex Tester. I'm definitely using this instead of .NET Fiddle now because I didn't realize, but it has this nice full screen thing as well, and it's much easier, more easy to read and stuff. Okay, so I'm going to create a class quickly. Okay, it'll be exactly like we did last week. I think we made person classes originally. We're going to stick to the book's shape example because it shows the concept of inheritance quite nicely, I think. So I'm going to create a class called Polygon, so just like multi-sided shape, basically. And it's just going to have length and width, exactly like it had at the end of last week's lecture. Okay, so exactly like the rectangle class, basically, that we had last week. While doing this, though, I'm going to show you both the long way and the shortcut way. Okay, so let's do that. So we create a new class. It's quite simple. We just say the word class. Okay, we give our class a name. Hopefully we're pretty used to that idea by now. Okay, let me make it so that I can scroll down a bit. Yeah. Alright, so that's our class Polygon. Okay, and we can give our class a bunch of different properties, right? Attributes, so just things that are associated with our class. So with the people class, we had the person class, we had height, weight, and hair color. With the rectangle class, we had length, width, and shape name. Here, we're just going to have length and width. Okay, length and width, we decided that we would save as doubles as well. Could have used ints, but double works nicely too. Okay, so we also discussed the difference between the word public and private. Hopefully you remember that as well. So public meant that it could be accessed anywhere. Okay, there was no access control. So other classes could access these attributes and methods if they were called public. And private just meant it can only be accessed within the class. Right, so the words, again, pretty intuitive what those mean. Okay, so we could say private double length, okay, to create a length variable. All right, that's just to create a length variable. And private double width. Okay, so we just pretty much exactly the same as normal variable creation, except we specify private. We also discussed that if we don't specify at all, then it's private. Okay, it defaults to private. But generally speaking, it's good programming convention to be explicit, right? So more for your benefit and other programmers' benefit than the code itself, right? Just so that you can understand what's going on. Okay. Cool. So we created these two variables, and then we had this issue. We were going, okay, well now they're private, but surely I maybe want to be able to read or see what these variables values are from outside the class, and I might even want to be able to change them from outside the class, right? So we had to deal with this idea of, okay, well how do we go about changing and viewing these variables if they're private variables? Okay. And there were two things. I hope, do any of you remember what these methods were called? I want to try to do a little bit of engagement even though we're miles away. Does anyone remember how we accessed and modified private variables from outside the class? What were the two little methods called? Getters and setters. Those are them. Yeah, those are them. Well done. Cool. Glad you guys. Accessors and mutators are another way of saying the same thing. Yeah. Awesome. Good stuff, guys. Okay, so we created these getters and setters, right? And how did we create those? They were methods. So you would, and they were public methods, right? That's important. They have to be public so that you can access them from outside the class, obviously. Quite intuitive why they would have to be public. Okay, so we say public. The standard is that it's the exact same name with the first letter capitalized. Okay, exactly like that. All right, and then you just say, okay, well, we're creating a little method. Okay, exactly like this. Oh, sorry. It has to have a return variable as well, of course. Okay. And in it, you just use these exact two words. Okay, so get. Okay, and what will get do? It will return this. Okay, return length. Let's leave it at this for now. Okay, just because this is what the book also does. Okay. Now the interesting thing to note here is that when you create this get statement, right? Should we discuss auto-implemented variables yet? No, probably not. Okay, but we haven't added a set here yet. Okay, so currently we would be able to read length, okay, but we wouldn't be able to alter length. Okay, and if we add the set variable, then we would be able to alter it as well. Okay, so what I wanted to mention here is a bunch of stuff is happening behind the scenes. Okay, because when I set this, I would say length equals value, for example. Length equals value. And where's value coming from? What is this? We don't create value anywhere, right? C# just knows what this means, okay, in the context of a set variable. All right, so there's a bunch of stuff happening behind the scenes here, but you can at least appreciate what it's doing. Okay, so we've added this get and set method for length, which means now if I create a polygon object, which hopefully you guys remember how to do that as well, if I create a polygon object, I'll be able to set the length and I'll be able to read the length. Okay, but we wouldn't be able to do this with width yet, because we haven't added a getter and setter for width. Okay, so let me create a polygon. We say polygon. Okay, obviously the name of the class, so this is giving a type. We give our polygon a name. I'm just going to call mine shape. You can call yours whatever you want. And then we say new polygon. Okay. Cool. Notice we haven't created something that we did have last time. We don't initially set the values of length and width. Do you guys remember what it was called? The method that allowed me to, when I create a new object, allow me to initially set the values of different properties inside that object. Do you know? I don't want to use the technical term because it'll give away the name of the method as well. Do you guys remember what we call those methods? Excuse me? So mutator allows me to set it whenever I want, but I'm thinking what would have allowed me to, let's say here, if I wanted to specify a length and a width here, right, inside this new polygon, what would I have to add here? What is the method that I would have to add here called? Does anyone remember that? Okay, if I said this is us constructing a new object, okay, it was called a constructor. Okay, but we'll discuss that now. Okay, so currently I create a new shape. We don't initially give this new polygon a length and a width. Okay, so I've created an object, but initially it doesn't have a length and a width because I haven't specified any here. All right, so I can then read. So that would be like console.writeLine shape.length. Okay, capital L. Why? Because that's the name of our public method, right? Little l would be our private variable. All right, and then we could say, but obviously currently the value of length is not set, so that's totally meaningless. So we would have to say shape.length, again capital L, and then it's exactly like setting the value of a normal variable. Okay, so now if I run this, we'll see that it prints out 20. Okay, see, it prints out 20. So it manages to set the value of length with the set variable, and it manages to get the value of length from our get. Okay, even though length is private. And that's pretty much the primary things we discussed last week. Okay. Now you can see this is a bit of a hassle to write all of this out, and if you were writing all of this out a lot, you would want a shortcut for this. Okay, you would want a shortcut to create these getters and setters, and those do exist. They're called auto-implemented methods. Okay, auto-implemented methods, and to use those, so I would have to create this exact structure for width as well. But as a shortcut for that, I can just say public double width. Okay, so exactly like I started the length getters and setters, and I can just say get, C# knows what that means, and set, C# knows what that means. Is it not easier to rather use fgets? I'm not sure what you're saying yet. Let's not get into anything else. Okay, so public double width get set. All right. So we've created these getters and setters. These are auto-implemented getters and setters. Okay. So now you can see this was very long to type out. We had to create the getters and setters ourselves, but C# does know what the word get means and does know what the word set means. Okay, so this will auto-implement this for us. But when we auto-implement methods like this, we also do not have to declare this variable here, this width variable here. Okay, it will not use this width variable. All right, so now this will work with width as well. If I say width equals 20, it will set the width to 20, and you can see this when I run it. Ooh, sorry. Length. Oh my gosh, length. That is so silly of me. Just change the W. That would be more convenient, to be honest. Okay, you see, so it knows what width is. So it automatically creates the variable width, capital W, and it creates the getters and setters. Okay, I didn't even have to declare that width exists. All right. And if you guys are wondering, last week, for those of you who remember, that is why our constructor wasn't initially setting the value of these variables, because this auto-implemented width doesn't actually use that variable. Okay, cool. I mean, I'll look into it, but let's stick to... It's not about what's easier, it's about what's testable, right? Okay, so... Cool. We've created a polygon now. Okay, all right. So I'm going to replace this length as well. I'm just going to delete this length. Okay, delete that length variable, and I'm going to replace that with the auto-implemented length as well. Okay, so I remove all of this code here. Just use the word set. Remove all of that code there. Just use the word get, and throw it all on one line. Okay, pretty simple, right? So now we've created a private variable, we've created its getter, and we've created its setter. Okay, there we go. Cool. So that was just revising the topics we were, well, actually we were revising them at the end of last week's lecture as well, but it's a pretty new way of thinking, I think, for a lot of people, so I think it's worth going over a lot. Okay, so now we've got a polygon class, and we can access it. It's exactly how you would expect. Okay, but there's no constructors yet, but we'll come back to that later on. Okay, so let me flip over back to the slides. Okay. So the book sets this up in an interesting way. I wouldn't say it's ideal. I think they could have done it a bit better, but there are sort of 4 important aspects of object-oriented programming within the book. I don't think they necessarily order them ideally, and so we're not going to follow the book's order in learning them, but we will cover all of the topics. Okay. This lecture in particular will focus on 3 of them. Okay, inheritance, polymorphism, and encapsulation. Now, the names might initially sound quite scary to you if you're not familiar, but you'll see that the concepts themselves kind of mean what these words intuitively suggest, okay, based on what the English meaning of the words suggest. So we're going to begin with inheritance. I think inheritance and polymorphism kind of overlap, okay, and encapsulation will be very quick to cover because you guys already know like 2/3 of encapsulation. Okay, so cool. Let's discuss inheritance and polymorphism. We're going to do inheritance first because this is a word that everyone knows already. Okay, inheritance. When you think about inheritance, what do you mean? Usually you'll think about I don't know, money or a house or something going from a older relative to a younger relative, right? Something like that. And it kind of means the exact same thing in programming, except with classes. Okay, so it really does mean what it sounds like. All right, classes can inherit from other classes. Okay, so I can define certain properties in a class, and other classes sort of downstream from it can inherit those properties. Okay, so there's a few nice ways to think about it. We've focused on 2 examples, this rectangle idea and this person idea. So if we had a person class, for example, we could have a doctor person class. Okay, so doctors are a type of person, right? So they could inherit from the person class. Nurses are also a type of person, so they could inherit from the person class. So what would that mean? It would mean a doctor has everything a person has, and you can add some extra stuff as well. Okay? A nurse has whatever a person has, and you can add some extra stuff as well. Alright? And the same is true for like a polygon class. Okay, there's a bunch of different types of polygons, right? Any multi-sided shape. And so we can define this abstract idea of a polygon. It can have like a length and a width. And then we can be more specific and go, okay, there's a square. It's a type of polygon. It has everything a polygon has and maybe a little bit extra. Okay. Likewise, there's a rectangle polygon. Okay, class rectangle polygon. And it has everything a polygon has and maybe a little bit extra. Okay. So this is the concept of inheritance, basically. Not super complicated, and we're going to see it in a worked example now. Alright, pretty intuitive that it would mean this. Okay, so I hope you guys are following this, and this is actually pretty much exactly how you write it inside C#. Okay, so let's explore that. So I've created this class polygon, and yeah, let's just do exactly what we did in the slides. Okay, we're going to create 2 classes that inherit from polygon. All right. I think actually let's start with 1 so that we can come to grips with the idea. Okay, so we've got a class polygon. It has a length and a width. Okay, so if I have these, if I have this class, I might now want to go, okay, there are two types of polygons that I care about currently. Rectangles, which can have different length and widths, and squares, which must have the same length as width. Okay? But they both have a length and a width. So I don't want to go and recreate the getters and setters for length and width inside my class square and class rectangle. Okay? And so what I'm going to do is I'm going to inherit length and width from polygon. Okay? And it's very easy to do this. All right? So I can say, as simple as this, I'll just say class. Okay? You give your class name, rectangle, and then you just put a colon. Okay? You just put a colon there, and you say what class it inherits from. Okay? Class. Okay? Exactly like that. I think not too complicated. Okay. And then we've got a normal class. All right. So this will inherit length and width from polygon. Okay. And we can use them here. So I'm going to throw down a rectangle constructor. Okay, a rectangle constructor. I hope you guys remember how to create a constructor, right? It has to be public because you have to be able to access it outside of your class. Okay, public. And it has to have the same name as your class, right? Has to have the same name as your class. And then you just give it the things that you want to save. Okay, so we want to set the length and the width. Okay. And how I would set those is I say, so notice, I haven't created length with a capital L inside the rectangle class. Okay. But because it is inherited, I can go length equals length and width equals width. Okay, so let's see this now. Oh, right, I have to go create a rectangle inside my... Okay, so we notice we can still create polygons directly, right? This polygon class still exists, and it works exactly the same as it was before. Okay, but now we also have a rectangle class. So I can say rectangle shape, or let's be more specific now, we can say rect equals new rectangle. Okay, the rectangle has a constructor that expects a length and a width, so we have to give it that length and width. Okay, so I'm going to make my rectangle 20 by 40. Okay, 20 by 40. All right, everyone happy with that? So when I run this, it will create that rectangle, and now we can make sure we can say console.writeLine. Console.writeLine rect.length. Yeah, length. Okay. And you can see it's 20, and if I say rect.width, that's going to be 40. Okay. So I hope you guys see what was happening here. So we created length and width in Polygon, okay, and we created its getters and setters there. And the class rectangle just inherited everything that Polygon has and made it here. All right, and set it here in the constructor, in the rectangle constructor. Okay, so I did not have to recreate the getters and setters. That's the important thing to note there. Okay, cool. All right, so that on the face of it is the concept of inheritance. There are two other words that are relevant here. Ooh, I don't know if I should... What would its use be in real life? Well, if we were making a geometry library now, its use much like a lot of these programming concepts, is just to save you time when coding. Okay, and you can kind of think of this as what you would want to do with classes in a way. Like if I was creating that dealership example still, I would create class car, and now instead of just creating an object for each car, I would inherit from car. Okay, and it gives you a lot more customizability. Oh yeah, no props. And it will give you a lot more customizability over each class car. Okay, it saves you time. So you don't. There's a bunch of abstract concepts. I mean, you can think about it literally in terms of like a geometry namespace that handles a bunch of shapes for you. You wouldn't want to reprogram the calculation for area for every single polygon. It's always the same, right? Length times width for most of these different polygons. So you just use that. Okay. And if you need to, you can alter it, which we'll see now. But yeah, the idea is that it'll save you time when creating all of these different classes. Again, a lot of this stuff you would only appreciate once you start creating very complicated code bases. So learning the concepts without doing those kinds of large projects is maybe a bit strange. But you can appreciate why the concepts of inheritance would be useful, I hope. Because like you can create a tree class or even a plant class, okay, a plant class, and then you can create a bunch of different things that inherit from your plant class, and they can all be subtly different. They won't just have different values for their properties, they'll have maybe entirely different methods, but they'll be related in a lot of ways. Okay, because that's the thing. If I'm just creating an object of a class, I can only alter its property values, right? What if I want to alter more about it? I want to alter its method, or I want to give it an extra property. Okay, all of these things can be done. All right. Cool. All right, so that is the concept of inheritance. I think that went over pretty well. It hasn't gotten super involved yet. What I also want to remind you, this section is a lot of theory. Okay, it's a lot of just memorizing what these words mean. So yeah. Okay, but cool. Let's use this class rectangle a little bit more. Let's say I want my rectangle to be able to calculate its area. Okay, so I didn't have to re-implement the getter and setter, but if I want to just add the getter and setter for length and width, but if I want to just add a quick method here, I can just do it. I can say public, it'll return a double. I can say get area. It won't take anything in because it just needs the length and width, which the class already has, and then you just say return length times width. All right, return length times width. And it knows where to find these because the getters were created in the class that it inherits from. And so now when I say rect.getArea, it'll return 20 times 40, right? The area of my rectangle. 800. Okay, perfect. So that works, right? Now, why don't we go ahead and create that other class? Okay, because we said that we have now a class rectangle. We also want to create a class square. And now we can see some of the fine-tuning that this allows us to do. Okay, so I'm going to go ahead and exactly like when I created the class rectangle, okay, I'm going to now just create a class square. All right, so I can say class square, and it's also going to inherit from polygon, right? Squares also just have a length and a width. The difference here is they must be equal. Okay, the difference is that the length and the width now have to be equal for it to be a square. Okay, so I'm going to create a constructor again. So I'll say public square. Okay, public square. Okay, and now we can say, all right, a square constructor doesn't need to take in a length and a width. Right, it just needs to take in one measurement, just a length, for example, because its length and width will be the same. Okay, that makes sense, right? So we only need to take in a length, because if we took in the width, it would be the same as the length. It has to be because it's a square. Okay, and then when I set the length, I can just say length equals length. Okay, and width equals length. All right, and these getters and setters are already implemented. Okay, so now my square constructor, I just give it one measurement. So now, even though I didn't have to recreate the getters and setters for length, so Alex, hopefully you can see why this is useful. I didn't have to recreate the getters and setters for length and width, but now I've used the same getters and setters to create both a rectangle class and a square class. Okay, and you can see they are fundamentally different. This only takes in one value. This takes in two values. Okay. And then we can say our square must also be able to calculate the area. Don't worry, we'll make this more sensible just now, but we can just copy paste that area method there. For our square, we could even make it length times length, but let's just leave it like length times width. Okay. So we've now got these two polygons, a square and a rectangle. Okay, and now we can go ahead and we've created a rectangle already. Let's create a square now. Square SQR, I'll call it, equals new square, and we just give this one number, and we only need to give it one number, and we can then go console.writeLine square.getArea. Okay, so it made creating these two different classes much simpler. I didn't have to go ahead and now create what would this be, like 8 getters and setters. Okay, instead I just created the initial 4, and you can imagine if I was continually adding more and more shapes now, you could see how this could get a little bit crazy, right? So if we weren't using a structure like this. So you see it manages to calculate the area of our rectangle and the area of our square. All right. So that's the concept of inheritance. You can see, so one class can have multiple descendants, if you want to call them. And now just to explain the more technical language, if you like, these classes that inherit from a class. Okay. So if a class inherits from another class. Okay, so rectangle inherits from polygon. Rectangle is called a derived class. Okay, derived class. It derives from polygon. Okay, it inherits from polygon. Okay, this means the same thing. I'm just telling you all of the different words that they could potentially use in a test. Okay, so rectangle here is called the derived class, and you would call polygon, this one that everyone inherits from, you might call that a base class. Okay, a base class. All right. So again, this section is a lot just about learning what words mean. Okay, we're learning what all of these different words mean. Okay, but let's do something even more interesting now. Okay, even better. So you see, we recreated the getArea method in both of these. I hope, as you guys maybe even expected, you don't have to do this, right? Both of them have a getArea method. Okay, both of them have this getArea method, so I can remove it in both of them, and I can just throw it in the polygon class. Okay, I can just throw it in the polygon class, and this still works exactly like it was before. So now it's inheriting the getters, the setters, and the entire getArea method. Okay. And it'll automatically make sure that one's rectangles and one is squares. Right. So, cool. So that's the concept of inheritance. I think this stuff is quite cool because it shows you, like, programming. You can do some pretty powerful things in this, right? This is displaying relations that maybe, you know, more traditionally you wouldn't think a computer would understand. Like, okay, a rectangle is actually, in the code, a type of polygon, right? And square is also a type of polygon, and all of these relations are clearly defined in the code. So if you ask the question, square is polygon, it will answer yes, right? We can actually, I can show you this. It's probably worth doing since things are running pretty smoothly. There is a nice operator that can do this. Let me show you. I'll I'm going to create, just to show you what this operator does, I'm going to say int x equals 6. I think we have seen this operator before. And I'm going to say console.writeLine. Okay, console.writeLine. X is, so the word is, int. Okay, so what this is word does is it says, is the thing on the left of the type on the right. Okay, so you give it a type on the right, and you give it a variable on the left, or whatever on the left, and if they're the same type, it will return true. So you see this returns true. If I say x is double, this will now return false. Okay, false. And what's cool is this will now work with our classes. Okay, so if I say, so rect, you see is of type rectangle, right? I can say rect is rectangle. Ooh, excuse me. Need to go have some water. And you see it returns true. Okay, but if I say rect is square, this will now return false. Okay, but if I say rect is polygon, okay, you see it's not directly a polygon. Okay, you see it returns true. That's very, like, you must appreciate like how it's kind of clever, right? That it knows that all rectangles are polygons. Okay, it also knows that all squares are polygons. Okay, so it's quite nice that you can define these fairly abstract concepts inside the code very directly. Okay, cool. And it knows these types, it understands the types. So that was just a quick brief introduction into the is, what is does. Okay, so is the thing on the left the type on the right. Alright, so cool. For now I'm going to remove our little square class here, because when we come back to this it'll be a bit annoying working with so many classes because I have to scroll down a lot. And I'll also remove our creation of a square here. Okay, so now we've just got a polygon class and we've got a rectangle that inherits from the polygon class, and it inherits a method getArea that will calculate the area of the polygon and also the length and the width. Okay, it has the length and the width, and our rectangle actually initially sets the length and the width as well when you construct a new object of type rectangle. Okay, cool. So that's inheritance. Let's go now and discuss the next big keyword. Okay, polymorphism. Right, now, as I was saying, this is the main part where this overlap happens. There's two words, okay, that we're going to be discussing under polymorphism, and they kind of are also inheritance, right? They're under this concept of inheritance as well. You'll see that polymorphism and inheritance are very closely related. Okay, so inheritance is this idea that a class, what we might call a base class, okay, can have a bunch of derived classes inheriting from it. Okay, pretty much means exactly what you would think the word inherit means. And polymorphism is saying that, let's say, a method inside one class can be used in a lot of different forms in different classes. Okay, so polymorphism literally means many forms. Okay, poly is many, morphism is form. Okay, so polymorphism, many forms. So we're just saying that things implemented, methods implemented inside a class can have many different forms. Okay, don't worry if you don't get that yet, we are only discussing it now. Okay, so let's do that. Okay, polymorphism. Okay, so I'm going to discuss that. So I'm going to discuss two major words here. These two words, abstract and sealed, in the book form part of inheritance. Okay, but the reason I'm explaining it this way is because I don't know, it makes more sense to me that way, and obviously that's the only thing I can gauge on properly, right? So we have this idea that we have a polygon, okay, and we have this rectangle polygon inheriting from it. Okay, So this is what we literally just programmed up. Okay. I now say, so I'll show you this in the code as well. We can currently we can create something of type polygon. Okay. We can create something, an object of type polygon, and we can also create an object of type rectangle. Okay. Currently we can do this. So let me show you. Here I create an object of type rectangle, okay, a rectangle object called rect. Okay, but I can also go ahead and create I'll do it above the rectangle instead, because that's the way it's in the slides. I can also create a thing of type polygon, right? Polygon shape equals new polygon. Okay, so nothing is stopping me. I can go ahead and create something of type polygon. So polygons can be objects. Okay, you can also inherit from a polygon though. Okay, so our rectangle inherits from polygon, but I can create a polygon object directly. Okay, and that's what these words abstract and sealed are trying to address. Okay, so let me let's go into this. So you can see I can create something of type polygon, an object of type polygon. I can also create an object of type rectangle. And we have this idea that rectangle is inheriting from polygon. So that's all I'm trying to show on this slide here. Okay, so we have the polygon class, something inheriting from polygon. We can create rectangle objects, but we can also create polygon objects. Okay, cool. So the words abstract and sealed allow us to control how this inheritance works. Okay, so we'll start with abstract. Okay, so what does abstract mean? If I make polygon, my class polygon, if I make it abstract, what will that mean? So this is what I'm trying to show here. So if we make polygon abstract, then we will no longer, this relationship here, polygon object, we wouldn't be able to do this anymore. We wouldn't be able to create a polygon object directly. Okay, so when you make a class or a method abstract, what you are saying is that this can only be used, or it can only be inherited from. Okay, you can only inherit from it. You cannot use it directly. Okay. Do you guys, at least, we're going to see an example of how to use this word abstract now, but do you kind of understand why you would want to define this? That you want to go, okay, there are some classes, okay, like polygon, where I don't want you to be able to create a polygon object directly. I don't want you to be able to create something of type polygon. Polygon is just an abstract class, okay? It's just an abstract thing that other classes can inherit from. Okay, so I can have rectangles, squares, rhombi, whatever, all of these different polygons. Okay, but you cannot create a polygon directly. That's what abstract allows you to do. It allows you to control that relationship. So if you say a class is abstract, so let me just show you inside the code. And it's as simple as just typing abstract class polygon. If I say this, if I add the word abstract here, then this polygon shape equals new polygon is no longer allowed. That's the only thing it changes. Okay, you are no longer allowed to use it directly. All right. Do we kind of get that? Can we gauge? Everyone happy with that, at least initially? So now if I try to run this, it'll break. So I can run it. Errors. Cannot create an instance of the abstract class polygon. Okay, so you are not allowed to create an object of type polygon because polygon is just abstract. Okay, it doesn't actually you can't actually create something, an object of type polygon. It's only used for things to inherit from it. Okay, so you can still inherit from polygon inside rectangle, but because polygon is abstract, it can only be used as a base class. You can never create an object of type polygon. Okay, so it's this line here that's giving trouble. And if I just like comment that out, so it's no longer code, you can see the errors go away, and our rectangle object still works perfectly. Okay, so rectangle can still inherit from the abstract class, but you can only inherit from it. Okay. Is everyone comfortable with that idea? Does anyone have any questions about this abstract word so far? By the way, I should have mentioned as well where you can follow through in the book. They cover encapsulation first. Yeah, this is on sort of page 49. Around page 49. Okay. No one has any questions about this abstract keyword so far. Okay. Now, you've seen, so our main method is public here, right? I just want to draw attention to this idea that, because you know what public and private mean quite well, I think, and you can see that classes can be public, but also methods can be public, and variables and properties can be public, right? This word public, it has a lot of meaning. It has one specific meaning, but a lot of different contexts, right? So it always basically means that you can only access it. Like public would mean that it has no controls, and private would mean you can only access it sort of in its context, right? Like in its class or in the project, something like that. Okay, so you can see that a lot of different things can be public and private, and likewise a lot of different things can be abstract and not abstract, right? So if it's an abstract class, that would mean okay, so we can only inherit from it. Okay, you cannot create objects of an abstract class directly. Okay, but like with these variables and the words public and private, a method can also be abstract. Okay, so let me show you what happens if I run this. Okay, so here, because we have marked the method as abstract, okay, it's saying that the method can't have a body because it is abstract. Okay, so how do I put this? Okay, let's say two other polygons that have very different area calculations. Okay, so we have triangles and we have rectangles. So a rectangle will have this get area method, right? It'll have this get area method. Okay, finally a question. Oh, come on, Rehan, don't get me all. Okay, so sorry, let me just think quickly. I lost track of my thought. All right. Okay, so in creating these abstract methods, all right. So we have rectangles and triangles. They're both polygons. Okay, but you can, and they both have get area methods, right? There's a way we calculate the area of a triangle, and there is a way we calculate the area of a rectangle, right? The area of a rectangle is length times width, and the area of a triangle is half base times height, if I remember correctly. Okay, so you see they have two different ways of calculating areas, but they both have areas. Okay, they both have a way of calculating an area. This is what abstract allows us to do. Okay, so in abstract method, I have to remove all that stuff. Oh, sorry. Wait, what am I doing? I need to... no, I must keep the declaration. Oh wait, we have to modify it. The modifier abstract is not. Try using a property instead. Oh, sorry. 1 second. Right. Okay, so I've created this abstract area now. Okay, the reason it's complaining is because we haven't implemented it yet. So yeah, this was the correct way of doing it. Sorry about that. Got a bit flustered. Okay, so we can create an abstract method. But notice when get area was defined inside polygon and it was abstract. So when I had this whole when here I had the return width times length, when I had this here, it was complaining because it's saying, no, get area is abstract. Okay, so it's not allowed to have a definition here. Okay, it's not allowed to be implemented. You can't tell it what to do. This, because it's abstract, can only be told what to do inside a class that inherits from Polygon. Okay, so now if I say, okay, get area is now an abstract method. Okay, that means now what it's complaining about is that rectangle is not implementing this abstract method. Okay, so why would we do this? So now if you create a triangle that inherits from Polygon, this forces you to tell the computer how the area of a triangle is calculated. Okay, and to specify that in a method called getArea. Okay, so it forces you now. It says, okay, if you want to create something that inherits from Polygon, there is this abstract method getArea that you have to define. Okay, so you have to now tell it how the area of this particular polygon is calculated. Okay, so this is what the word polymorphism is referring to. Okay, so we've got this getArea method, and we have a class polygon. Okay, a bunch of things inherit from this class. All right, and this getArea method can have many different forms in all of these different classes. Okay, is that starting to make more sense? Hopefully, let me actually program it up. Okay, so basically what this is complaining about now is, because we've got this abstract getArea method, inside our rectangle class you have to define getArea. Okay, so how we do that is with this other word. Again, as I mentioned, it's this section is a lot of words. It's a lot of words. Okay. Okay, let me write it out. So we have to, inside the rectangle class, we now have to implement the getArea method. Okay, because it's this abstract method. So to tell C# that, okay, I know there is this method getArea, polygon.getArea, that is abstract, and so it doesn't have an implementation yet. I need to tell it how to calculate the area of this rectangle. Okay, and to tell C# that is what you are now doing, that you're currently defining this getArea method, you use this word override. Override. So what is this saying? It's saying, okay, we're overriding the initial version of this method. Okay, we're overriding the initial version of this method. And this word here is the most important word you must associate with polymorphism. Okay, so when someone says polymorphism, you must think override. Okay, all right. So now I can define return length times width, and you can see that that works successfully. Okay, so let's see what's going on. So in the book it says C# doesn't support multiple inheritance. Is it a security feature or a limitation of the language itself? Multiple. Oh right. Where is this said? Can you tell me what page? I want to see. I want to make sure. I want to make sure I don't lie to you. Page 51. Okay, where do we see this? All classes. Oh yes. Okay, so what they're referring to here is, let's say we have how do I put this? What is something? Okay, I can't even think of an example where you would want multiple inheritance to be. Okay. So let's say we have a vehicle class. Okay, a vehicle class. So to include all vehicles, trucks, cars, motorbikes, for example. Okay, a vehicle class. And we plan that all of our different classes are going to inherit from this. Okay, all of our different classes of type vehicle are going to inherit from this. but then we also decide, okay, so we have this vehicle class, and we have a car class. Okay, and when we create this is going to become quite convoluted. So the primary thing I would say is it's because you don't need multiple inheritance, but I'll try to prove it to you with this example. Okay, so we've got a vehicle class, picture it in your head. We've got a car class. Now you have to realize what's happening here. Class is not inheriting from vehicle. Okay, they're separate classes. Class vehicle, class car. Okay, I then create another class called Mercedes, let's say. Okay, so we've got a class Mercedes, class vehicle, class car. Okay, the vehicle, so Mercedes is a vehicle and a car. Okay, so we're going to say it must inherit from both vehicle and car. And C# will say, no, that's not allowed. Okay, so basically you're not allowed to say this inherits from polygon and shape. Okay, you're not allowed to do that. Okay, so it's kind of like, if you're going to do this, just define like another structure. Okay, let's see something quickly. I want to try. How can I show you this quite nicely with our little shape example? I mean, I could create a class shape and a class polygon and show you that rectangle, but it's kind of like, how would you even type it, right? So if you were trying to do that, you might say something like that. Okay, and all they're saying is C# isn't going to understand this. Okay, but I think about it in terms of when would you try to do that? When would you want to inherit from multiple different classes? And yeah, I guess you could see it. It's not really a limitation in a way, because allowing that would create a bunch of clashes, right? It would create a lot of clashes where, let's say you implement getArea in shape and you implement getArea in rectangle. In polygon. So now you have these two getArea implementations, and you try to inherit from both of these classes. You can see, like, okay, which do I choose? So I wouldn't call it a limitation. I would say it's more just like they're just telling you we don't allow this, and I don't see where you would really want it. Okay, because you can always, what you can do is have like something inherits from something. Okay, so like you can I think this is allowed, so let's try that. I'm going to create I haven't experimented with this, but we can check it out. Let's try that. So I'm going to create I'll just call it a class shape. I 100% know this is allowed because C# does it all the time. It's just hidden from you. We can say string. Sorry guys, we're digressing a little bit, but this is for interest's sake as well, right? So I think it's worth doing. Let's make this an auto implemented thing as well, just to really drive home that point. So I'm creating a string here, and I'm automatically creating its getters and setters as well. Okay, and we're just going to call this shape, not that's bad convention. I'm going to call it sname for shape name. Okay, so we now have this thing shape. Okay, and I'm going to make my polygon inherit from shape. Okay, and then rectangle inherits from polygon. I think this should be allowed. Yeah, and that's allowed. Okay, so you can do this. So what's not allowed is inheriting from two, like, at once. Okay, so one class can't inherit from two, but you can, like, something inherits from something inherits from another thing. Okay, and it's kind of like, what structure wouldn't you be able to define in that kind of in a way? Maybe don't think about this too much, because in a way it is different from what the word inheritance means in the real world, right? Because like you can inherit from your mother and your father simultaneously. C# classes aren't allowed that. Okay, they can only inherit from one thing at a time. Okay, I wouldn't necessarily call it a limitation, though. It's more just like it's very difficult to set it in a way that would make that safe. Yeah. But also not, when I say safe, I don't mean security safe. I mean safe for you as a programmer, and like it'll create a bunch of clashes. Yeah. Okay, that was a nice little digression. But let's get back on track now. What were we talking about? Right, overriding get area. Okay, so hopefully you guys get this idea. Abstract, it means that it can only be inherited from. Okay, you can never use it directly. It has to be inherited. Okay, so an abstract class, okay, you cannot create a polygon directly. Okay, you cannot create a polygon directly. You have to inherit from it. Okay, that's what abstract means. All right, so if I remove abstract, then we can go ahead and create polygon objects directly like this as well. But you can see why sometimes you wouldn't want that, right? Because like in thinking about it in terms of the person example as well, right? If we created a thing of type person and a bunch of actually maybe that's not the greatest example. Let's stick with cars. Cars always work. So if we create a class of type car and then we want to create a bunch of different car brands, you'll never really want to be able to create maybe, depending on your use case, you probably wouldn't want to be able to create just a thing of type car, right? All cars must be, more fundamental than just this is a car. Okay, so then you would say, okay, this is an abstract class. Cars exist, but they have to be inherited. Okay, they have to be derived, rather. They have to be derived. So you can only derive from the class. Okay, we've drummed on about this a lot, and there's no questions about it, so I assume everyone's comfortable with this idea. Okay, I was quite proud of this slide. I think that displays it pretty well, right? So you're not allowed, if it's abstract, you're not allowed to create an object of it. Okay, so now we go back to our original structure. So polygon is not abstract anymore. Okay, so now we can create polygon objects directly. Okay, so let's discuss this other word. So these words abstract and sealed, you must think about these two words when thinking about inheritance, and the word override you must think about when thinking about polymorphism. Okay, so that's what I mean where these topics are overlapped, and I didn't really know how to convey that, but cool. So what does sealed mean? Okay, so if I make polygon sealed, that means this relationship is now illegal. Okay, it's not allowed. Okay, so sealed means that now you are no longer allowed to inherit from polygon. Okay, if I make polygon sealed. Likewise, if I made rectangle sealed, you wouldn't be allowed to inherit from rectangle. Okay, so that's all sealed means. So if I made polygon sealed, you wouldn't be allowed to inherit from rectangle, which would kind of make this whole last bit here not possible. Okay, so sealed means you're not allowed to inherit from it. Okay, you're not allowed to inherit from it. So that's just what the words abstract and sealed means. It's just allowing you to control inheritance. Okay, so we can see this sealed one now. It's kind of going to break our entire example, but let's just go for it. So if I type sealed here, you can see C# recognizes the word, and if I try to run this now, we get a whole bunch of errors, and it says rectangle cannot derive from sealed type polygon. Okay, that's the primary error. Okay, so basically we're just saying, all right, in making this sealed, it's no longer allowed to be inherited from. Right? I'm just fixing it so that the example really highlights the sealed idea. Okay, so I'm going to remove the override. Okay, so now because class polygon is sealed, I'm not allowed to inherit from it. Okay, I'm not allowed to. class rectangle cannot derive from sealed type polygon. If I remove the sealed, what's up?
Can we please take a quick break?
Ooh, oh yeah, sorry, we've been going for a whole hour and 5 minutes. Yes, of course we can take a quick break. Let's go 10-minute break, say, or 5-minute break. Yeah, we don't have too much more to cover in today's lecture. We've gotten through quite a bit. So yeah, let's do 10-minute break. Come back at, what time will that be? 3:45. And actually, I need a break as well. I want to go get some water. Yeah, 3:45, guys. Sorry I went over time there. Just lost track. Cool. I think we can get started again. Let me double. Ooh, geez, 23. Yo, okay. It's quite a few. Oh wait, they asked that I do this from now on. That I say. Cool. All right. Yeah, let's get started again. Cool. So, what have we learned so far? Let's go back to the slides and remind ourselves. Okay, so we've learnt about the concept of inheritance. Okay, so we can define what's called a base class, and from that base class we can create a bunch of derived classes. Okay, not too complicated, and there are two keywords that are important here. Okay, that control how inheritance flows and how inheritance can work. Okay, and they were abstract and sealed. Okay, someone's got quite a bit of background noise. Can you mute your mic, please? So we have two words that control how inheritance can flow, and they were abstract and sealed. Okay, abstract meant that a class can only be inherited from. Okay, like so. It can only be inherited from. And sealed meant that a class cannot be inherited from. Okay. Under this abstract idea, there's another word that we had to learn called override. Okay, override, that allowed us to change the function or change the implementation of a method that is provided earlier. Okay. So override what that method was doing. Okay. And I hope you can see, like, everything's pretty sensibly named, right? All of the words make sense for what they do. So yeah, hopefully we can see that that is the case now. So yeah, let's maybe finalize this example just so that we really get an understanding. Okay. Cool. So we have this getArea method. Tell you what, I'm gonna make the class abstract now. Okay, I'm gonna make the class abstract. Can I create an oh right, yeah, because currently we're doing that there. Cool. So we know, as we're told immediately, because the class is abstract, we can no longer create an object of type polygon. Okay, that's not allowed, right? So now the polygon class can only be inherited from. And we said we want to create a class rectangle and a class square. So I'll now just quickly create the square class, and we had class square also inherits from polygon, and again we can only inherit from polygon here. right? We cannot create polygon directly because polygon is an abstract class. We cannot create polygon objects directly. Okay, we can create our square constructor. Right, and the square constructor needs to take in only a length or only a width, because the length and the width are equal. Okay, so then we could say length equals length and width equals width. Okay, cool. So that handles that. So now we have squares, rectangles, and polygons. Polygons can only be inherited from. We might say that you cannot inherit from rectangle, right? Let's say we wanted to make that the case. Then we just throw in the word sealed here, right? So this is just making our code very secure. So now you cannot go and create another class that inherits from our square class. Okay, it is sealed. Okay, and let's see, what else would we do here? Oh, right, there is no width here. Sorry, I must say length or length. Sorry, that was a weird mistake. Okay, so yeah, I think that's pretty much this example complete. The name length does not exist in it. Did I spell it wrong? I did spell it wrong. Cool. So yeah, that's this example complete. So we defined an abstract class polygon. We created two derived classes, rectangle and square. Both of them automatically have getArea implemented. They have slightly different constructors, and their getters and setters are also automatically implemented by Polygon. Okay, and we made these getters and setters the auto-implemented versions of them. Okay, so a lot of new sort of keywords and stuff being thrown around, but yeah, hopefully you understand their meaning and are comfortable with that. Okay. Cool, I suppose we can move on to the next idea. Actually, before we do, I want to sort of reset and explain one other keyword. It's a very simple one, and in C# at least it's used in a particularly niche case. Okay, but I want to show you that quickly. It's very simple. Okay, so I don't have to remove any of our existing example. I'm just going to create another class to show you what this does. Okay, so I'm going to create a person class. All right, so we've now got our polygon and rectangle thing. We're stepping away from those now, but in our Rex tester namespace, we're also going to have a class person. Okay, class person. Cool. Person is going to have let's say height and weight again. Those seem to be working pretty well. So we'll say, should I make these public or private? It doesn't really matter. So I'll say private, private double heights, something like that. And we'll say public int weight, for example. Okay, so I create two attributes in my person class. I then want to create a constructor for my person. Okay, and we did this in a very, we've done this before. It wasn't too bad. It needs to be public. Your constructor needs to be public because obviously you're going to be constructing people, objects from outside this person class. So it has to be public, and it must have the exact same name as the person class. Okay, like so. All right. And it needs to take in two things, right? A double to set the height and an int to set the weight. Okay, and previously we called these h and w. Okay, and then our constructor would go height equals h and weight equals w. Okay, now there is one extra keyword that they sometimes ask about. It's quite simple, but obviously if you haven't seen it before, it would be totally new to you. So I am just going to show it to you here, and let's just show that this works quickly. So I'm going to say person1 equals new person. We give them a height, let's say 1.7, and a weight, let's say 50. Okay, so Cool, we now create a person. We can just double check that this, oh, right, okay, height was private, weight is public, so we'll be able to view the weight. So let's say console.writeLine, and we'll be able to say person1.weight, and we would expect it to give us 50. Okay, so let me just run this, and it gives us 50. Okay, so we've created this class person. It has 2 properties, and it has a constructor. Okay, now what I want to show you is that you can see this is a bit. I mean, I wouldn't complain too much about it, but someone did, and so they decided to fix it. But you can see that using W and H here is maybe a bit unintuitive. Okay, it's not the hugest deal, but it's slightly more difficult to understand than if this was height. Okay, and so there's a way to adjust for this. Okay, so let me show you what would cause the confusion. Ideally, I would want to take in a double called height, and I would want to say height equals height. Okay, but this will obviously cause problems because okay, it's in this case it's okay because I think because it's private. Let's try this with weight as well. Maybe C# is just specifying it automatically. Okay, no, awesome. It's all right. Oh, let's say weight. So it is automatically using the local ones. Okay, it made it 0. Fantastic. So it does break. That's what we want though. Okay, so what's causing the confusion here? When I say weight equals weight, I think it was breaking because it's public, but this generally you would see why this is a problem. Okay, so weight equals weight. Currently, it doesn't know. When I say weight equals weight, it doesn't know that I mean this weight must be set equal to this weight, right? It doesn't know which way I'm referring to it. Like, should it set this weight equal to this weight, or should it set this weight equal to this weight? Okay, which way should this be going? Okay, and for this particular use case, and it's occasionally used elsewhere, but you don't need to know about those ones. There's this keyword this. Okay, this. So it'll say this dot height, meaning this one, okay, the one inside the class, must be equal to this height. Okay, so that's all really that you need to know that this keyword is doing. Okay, so if you say this dot something, what it means is the version of this inside the class. Okay, that comes from inside the class. Do you guys get that? It's a bit silly, but I do have to show you this kind of stuff for if it ever comes up in a test. Okay, and then we'll move back to our other examples just now and the new stuff just now. So basically, if there's a conflict between naming, okay, then you can use this dot height to refer to person's property height, okay, and person's property weight. Okay. Otherwise, obviously, it'll cause some conflicts. Like this will cause confusion, and so it'll say weight is 0, even though I set weight to 50. Okay, but if I say this dot weight, it knows which weight I'm referring to. Alright. A bit strange, but there you go. It's not difficult to understand. It's just weird. Okay, cool. Alright. So yeah, that's just a brief interlude explaining what this keyword means. Okay, so this dot something. Okay, means take the property version of this class that corresponds to that name. Okay, cool. All right, so going back to our initial example, there's one more word that I wanted to describe in this lecture. We'll probably end a bit early today because I don't want to start on things that I haven't prepared slides for, because like last week that'll just cause problems. Okay, so, and that's encapsulation, and this section will be super quick for us because we've already discussed what public and private mean. So I think it's page 48. So page 48, there's a little table. They in the book they put this section before inheritance, which I think is quite silly. because then later on in the encapsulation section, they say that you haven't been taught enough to learn a lot of this stuff. So, yeah. Encapsulation, where I decided to do this after the other two, and I think it's just generally more sensible. So, encapsulation, there's 5 different modifiers. So you've heard of 2 of them already, public and private. Okay. There's also one called protected. Okay. Now in your book you can see that they have 2 extra, internal and protected internal. Okay. I don't want to tell you about these now. Okay. And also in tests they won't be brought up. It's kind of similar to a names, like what you have to know about namespaces. It's not frequently brought up in detail, you just know it's a set of classes, right? Likewise with this internal one, it's just restricted access to the project, or what they call the assembly, but it's the project, the C# project. Okay. But anyway, we won't talk about internal and stuff yet. So public, private, and protected, you already know what public and private mean, right? We can just do one more example of each of them, just for those of you who aren't yet feeling totally okay with public and private. So yeah, let's do that quickly. Where should we do this becomes the question. Yeah, okay, I'm gonna see, let's create public string name, string shape name equals new, not new, just nothing. Yeah, okay. So rectangles now have a property called shape name. Okay, let's create something of type rectangle. So I'm going to say class, no, what am I doing? Rectangle rect equals new rectangle. Okay, something like that. And we have to specify a length and width for our rectangle, so I'm just going to say 2030. Right, so exactly like that. Now, cool. So we have this public variable called shape name inside rectangles as well. Okay, so this rectangle will work normally. Let me just show you that. So I'll be able to say console.writeLine rect.length, for example, and that's going to give me 20, right? Cool, and it gives me 20. Right, so that was just, and all the normal things will still work. Get area will give me 20 times 30. Ooh, oh, sorry, I have to call the method. Okay, get area. Okay, 600. All right. So, we've got that. Now, shape name, right? This extra property we created inside rectangle, shape name, is public. So this will work. Okay, shape name is obviously empty currently, but because it's public, we can change it. So we can set it, shape name equals rectangle, for example. Okay, rectangle. We can change it and we can read it from outside the class. Okay, when rextester eventually works. Yeah. Okay, so you see I said rect.shapename equals rectangle, and then I printed out shape name and it changed shape name to rectangle. Okay, so we're happy with that. That's because it's public. If I change it to private, then you can see that we're no longer allowed to access this. Okay, we're no longer allowed to access it. It'll say rectangle.shapename is inaccessible due to its protection level. And hopefully, as actually you guys answered it at the beginning of the lecture as well, when it's private like this, we have to use getters and setters to be able to alter it. Okay, so you know what public and private mean, right? So check. Okay, but we don't yet know what protected means. Okay. So the reason why we would prefer to explain inheritance before encapsulation, okay, is because what protected means is that the variable or the property or the method, whatever, is restricted to being used inside the class or by anything that inherits from the class. Okay, so what do I mean by that? So let me show you. So if inside polygon, okay, so I'm going to quickly remove, okay, I removed shape name from there. Fantastic. Okay, if inside polygon, okay, I say private string shape name, okay, rectangles and squares would not be allowed to change shape name. Okay, because its access is restricted to inside polygon. Okay, we understand what private means. It means it can only strictly be used inside this class. Okay, so it wouldn't be able to be used by rectangles and squares. Okay, even though rectangles and squares inherit from polygon, because polygon is private, rectangles and squares would not allowed to be able to change it. Okay. The nicest, and so this is why protected exists. Okay, let me just show you this quickly. If I say, hopefully it breaks, that would be ideal. They don't usually demonstrate it like this, but I think this might be a better way of, yeah. Okay, so you see, I tried to set shape name here. It is a property, it's been inherited. But it goes polygon.shape name is inaccessible due to its protection level. If I change this to public, okay, and run that, this is now okay, right? I'm allowed to set shape name equals rectangle because this is accessible everywhere. But now, because it's accessible everywhere, it would also be accessible here, right? And I don't necessarily want that. Okay, so let me try to explain it maybe a bit better. So you can see it's currently accessible here as well. So what I want you to see is that there's kind of no, again, we're at this problem where there's no middle ground, right? Where I can go, okay, I can set it public, in which case it's accessible inside polygon, inside rectangle, and inside any other class. Okay, it's accessible everywhere. I could make it private, in which case it's accessible inside polygon, okay? It's not accessible inside rectangle, and it's not accessible inside any other class, okay? But what if I want a variable that is accessible inside the class itself, a property rather, that's accessible inside the class itself, accessible inside any class that inherits from that, from the base class. Okay, so I want shape name to be accessible inside polygon and inside anything that inherits from polygon. And lastly, I want it to be accessible when, I don't want it to be accessible in any other class. Okay, so I want it to be accessible inside polygon, inside things that inherit from polygon, but nowhere else. Okay, so basically I mustn't be able to access it in main here or in any other class. I must be able to access it in polygon and in rectangle. Okay, and that's what the protected keyword is there for. Protected. Okay, so this means it's accessible inside the class or in anything that is derived from the class or anything that inherits from the class. So now it's not accessible here. Okay, it's not accessible here anymore, which is why it was complaining. But it is accessible here. Okay. Do you guys understand the use of protected so far? So it's like a nice middle ground between public and private. Okay, so private means that it's not accessible by any other class, including all the classes that inherit from you. Protected means it's accessible to the classes that inherit from you, but none of the other ones. Okay. And obviously it's always accessible by you, by the class itself. Okay. Any questions about protected so far? No. Okay. Good stuff. So where might this be used? We did a silly example here where we said, okay, so there's a shape name, and so all polygons have shape names. Rectangles and squares, because they inherit from polygons, will be able to see shape name, right? Because it's protected, you're not able to see or change shape name outside of any of these three classes. Okay, outside of Polygon or the things that inherit from Polygon. Okay. But inside the things that inherit from Polygon, you can set it and see it. Okay, so that's what protected means. Okay, where is this frequently used? So let me give you a quick example. So where this might be used in quite a nice way that they show in the book is you would say, okay, I have this length variable, right? I want everyone to be able to see the length of my polygon, okay, whether it's a rectangle or square, and I want everyone to be able to see the width of my polygon, okay, whether it's a rectangle or square, but I don't want just anyone to be able to change it. Okay, so let me show you that here. Here we create a rectangle, right? I'm able to both console.writeLine. You can see that I go rect.length. Okay, let's say length. Okay, I'm able to see length, and when I run this, it'll print out 20. Okay, but I'm also currently in main here able to change length, right? I could set length equal to 30, for example, and make my rectangle a square. Okay, what if I don't want to allow that? I don't want you to just be able to make this rectangle a square. Okay, you can't just change length's value when you're just anyone. Okay, rectangle can change its own value. Okay, rectangle has to be able to set length, obviously. Rectangle has to be able to set this variable, because without it you wouldn't be able to create a rectangle. Okay, but other classes, not rectangle, other classes must only be able to see rectangle. They mustn't be allowed to change it. Okay, so how would you do that? Well, you just say protected. Okay, so now I say get. So get is accessible obviously inside Polygon. It's accessible in anything that inherits from Polygon, and it's accessible in everywhere else, right? It's accessible everywhere. But because set is now protected, okay, it's accessible inside Polygon, it's accessible inside rectangle because rectangle inherits from Polygon, but it's no longer accessible inside main. Okay, because set is now protected. So when I run this, you can see it says polygon.length cannot be used in this context. Okay, so because the set accessor is inaccessible. So we're not allowed to access set inside main anymore. This line here, that is not allowed. You're not allowed to change the length unless you are actually inside rectangle. And so now rectangle could go ahead and implement its own little set method that will control when you are allowed to set rectangle's length. Okay, so that's what the protected keyword means. I imagine there'd be some. So protect determines who can read and who can write, exactly like public and private do. Yeah. All of these things, public, private, protected, and the two other ones that will not be named on page 48. They're called access modifiers, and all of them will control who can see and who can write. Okay, who can read and write. So the problem, so what I want you to see, public and private, we understood why those existed, right? When we started creating classes, our person class, for example, we understand why you might want the variables to be totally public, like if you have a name, for example. Anyone can change the name, anyone can see the name, okay? As just a silly example, then you would make it public, okay? But certain things you wouldn't want to just be able to alter, right? You wouldn't want to just be able to alter specific things, so you would make those private, okay? So in that, when we're creating just a single class, all you needed was public and private, right? But what you must see is that when we suddenly allowed you to inherit from classes, okay, there was a new problem. Okay, because private meant that it could only be accessed inside the class, and public meant it could be accessed everywhere. Okay, when we have this idea of inheritance, we introduced this problem of, okay, well, what if I want it to be readable and writable inside my class, but also inside any class that inherits from it? Okay, but I don't want it to be readable or writable. So access modifiers. I guess you could see it in that way. In general, you're going to control the privacy of code in a way very different to that. But I would say maybe it's not safe thinking about it that way. Don't think about it that way. Yeah, think about it in terms of read and write privileges. Okay, think about it in terms of read and write privileges. Because when you're controlling that, it's not as simple as just making all your code protected and stuff. Because open source is more about whether or not people can see the code itself, right? See and change the code itself. This is more like seeing and changing the values of certain things. Okay, so obviously if a system is open source, then you could just go ahead into the code itself and just change it, right? You can just remove the protected, right? So you could have protected variables inside an open source program. Yeah, it's more like that's determining whether or not you can alter and see the code itself, whereas this is saying can a user alter and see specific values, right? So it's like different levels, basically. Yeah, so what you must see, public and private, okay, if we were just working with rectangles, okay, you can see public and private are enough to solve all our problems, okay, if rectangle wasn't inheriting from anything, okay, because private just means, okay, I need to control how read and write privileges work, and I only have my class and everything that's not my class, right? There's only those two things, right? If we were only working with a single class that wasn't inheriting from anything, then it would just be, okay, I have my class and everything that's not my class. Private means I can access the things here. Public means I can access them anywhere, okay? But when we introduce inheritance, there was a new layer, right? There was a new problem where public and private are no longer enough, okay? Because public means that it's accessible anywhere. Private means that it's only accessible here. We needed a third option where it's accessible only here, right? In things that inherit from Polygon and in Polygon. Okay, that's why we needed this extra word protected. So that's the problem that this word protected was solving. Okay, there wasn't this extra idea, right? Where, okay, now I don't just have a class and everything else. I have a class, things that inherit from me, and everything else. Okay, so we added this extra layer, and so we needed this extra word to describe that. Okay, yeah, all the encapsulation stuff is a bit hectic, but for now, just what you must know about encapsulation. Actually, it's not too bad, is it? No, it's not really that bad. Public, accessible anywhere. Private, accessible only inside the class. Protected, accessible inside the class and in anything that inherits from it. Okay, so it's just these three words, basically. There's two other unnamed words on page 48, but we're not talking about them yet. Okay, so that's encapsulation. That's polymorphism. What do we mean by polymorphism? Many forms. Okay, so we have this implementation of a method, and there is this word override, okay, that allows me to change what that method does inside my derived classes, okay, inside classes that inherit from my base class, right? And the other concept that we learned is inheritance. Okay, so inheritance, two major words, abstract and sealed. Okay, abstract meant that a class can only be inherited from. Sealed means that a class cannot be inherited from. Okay, and we know what the concept of inheritance is, I hope. That's pretty intuitive. And that is everything I wanted to cover this lesson, actually. Oh, the other thing we learnt about is the this keyword. Okay, the this keyword is just a silly thing. It's very easy to just cover by yourself. So if you ever forget what the this keyword is, it's on page 38, 39, and the example there is pretty self-explanatory as well. Okay, so what the this keyword means is that if you say this dot the name of some property, it means the property inside this class. Okay, so that allowed you to name things the same way inside and outside the class. Okay, so the this keyword, pretty niche, pretty silly thing, but do know what it does, because the kind of question you would get about that is, okay, you're creating a constructor, you have a length variable, you have a length property, but also a length variable being passed into the constructor. How do you deal with this? You need to say this dot length equals length. Okay, the this keyword. Right, and that is everything for today, guys. We have finished 10 minutes early, so if any of you have any particular questions still, but yeah, I mean, so those last two I got, hopefully I addressed them okay. Protect determines who can read and write. Yeah, but so does public and private, right? All of the access modifiers are essentially just determining not really who can read and write, more like which classes, right? So don't think about it in terms of people. Okay, that might confuse you. Rather think about it in terms of classes. Okay, so which classes can read and write? So access modifiers determine if a program is open source. Yeah, I think I addressed that one okay. Yeah, open source is more about who can see the code, right? So if it was open source, obviously there's a bunch of loopholes actually, but I mean not loopholes, but you have to jump through a bunch of hoops to actually change open source code. But yeah, hypothetically, it doesn't matter if the variables are private or protected or whatever. I could always just change them myself, right? So yeah, you would still have protected and private properties inside open source code because it's more about usability. It's more about usability than whether or not you can change the code itself. All right. Any other questions, guys, in the last 10 minutes, or shall we call it there? Ooh, I have a question for you. Are we sticking to 2:30 from now on?
I'm okay with 2:30.
Cool. Okay, I'll schedule...
2:30, please, sir.
Okay, fantastic. Okay, everyone's... Well, all three people of the 23 people agree. So we will be sticking to 2:30 unless someone protests. Okay. Cool. Alright, I think we can call it then. Think about if you have any other questions. Ooh, there was a nice... Maybe, if you're bored during the week, I guess there are these nice things. Well, I guess it's not nice to you. They're called homework. Get excited. But yeah, if you feel like it, you could create, hypothetically, over the next week, you could create your own unique namespace, class, and constructor example. So like your own little example of this, not with shapes, or just Google one. And you could write a short paragraph explaining inheritance and polymorphism. Almost a 100% chance that none of you are going to be doing this, but if you feel like it, go ahead. Okay, maybe a little bit earlier. Okay, I don't know. We can discuss it more in the WhatsApp group. Okay. Cool. So. Cool. Yeah. Okay. I'll schedule. So for those of you who aren't liking WebEx, I'm sorry. I'll see again if we can solve some of the problems that people are having with Microsoft Teams. Are there other niche access modifiers? Yeah. So there's two of them. I guess actually in the last 8 minutes, and I am going to be... Some people won't like it because they'll go, oh no, but I'm here to learn. But in a way, this is how learning works. Okay. There are these two other access modifiers. Wait, what was it? I said page 48. Yeah. Internal and protected internal. Okay. Protected internal 100% just ignore. If it comes up in any of the past papers that I look at, we can discuss it then. But internal, what this means Now, this is all I'm going to tell you. We're not looking at examples of this because it's just, it won't come up enough to justify spending the time on that, okay? But internal just means it's only accessible inside the project, okay? The other word that they'll use to say this is assembly, okay? It's only accessible within the assembly, okay? And you just, again, like with certain things, right, there are a whole bunch of programming concepts, right? Like, similar to when we were going over the different exceptions that occur in a try-catch statement, it is absolutely impossible for us to cover them all, okay? And this is one of those, all right? So internal just means it is accessible within inside the project. If it comes up in a multiple choice test, like, which of the following access modifiers do you pick if you only want it to be accessible inside the project? You just pick internal, okay? We just know the definition of it. You'll almost certainly never use it, okay? If you become a developer at Microsoft one day, then you can come back and slap me maybe for not telling you what internal does. But in general, this won't come up. So that I would consider a niche access modifier, okay? We would cover that in maybe lesson 1000 or lesson 200. Okay, cool. All right, yeah, let's call it there for the day, guys. Thank you for joining. Enjoy the rest of your week, and see you next week Friday.
Thanks, sir.
Cheers. I'll assign a host. It will be randomly assigned. Congratulations, 101DE. Oh, okay, he left too. Alex is there. You go. Yeah. Awesome. Kazam. Finish recording.